Hello everyone, in this presentation we will see together how to improve your EKS security posture with threat model. My name is Maxime Cockrell, I'm a Microsoft MVP on the Azure and security technology. I'm also a principal Kubernetes cloud security architect for a large financial organization in Canada. I'm passionate about cloud technology, more specifically cloud native technology and cloud security technology. I'm a tech blogger since 2012. My blog is zigmax.net. If you have any question after this presentation, do not hesitate to reach me. I'm available on LinkedIn, for example, or you can send me an email if you have any question. A quick disclaimer before to start this presentation. Any of your opinions expressed in this presentation are only my opinion and not necessarily represent the view and opinion of my employer, its ownership, management, or its employee. A quick introduction to Kubernetes. In Kubernetes, we have two main components, the control plane and the data plane. The control plane, that component will orchestrate and manage the Kubernetes cluster. In the control plane, we have a controller manager. We have also an etcd cluster. The etcd cluster will be useful to store the Kubernetes secret, the config map, for example. We have a scheduler, and we have an API server. The role of the API server will be to do the link between the control plane and the data plane. On the data plane, you can imagine that as your EKS worker node, or maybe your different virtual machine where your workload will run. On the data plane, what is important to understand is the three main components. The kubelet. The kubelet is a critical component because this component will be used to do the interaction between the API server and the data plane, and the EKS node more specifically. The kube proxy, the container runtime. The container runtime, in the case of EKS of Azure Kubernetes services, that will be containerd, but previously that was Docker. And to manage this cluster, we have two main components. kubectl, that is a command line tool used to interact with the control plane. And we have also the possibility to have a UI dashboard. This slide, that was only to put the foundation, to bring everyone up to speed with the Kubernetes foundation. More specifically, in our case, for this presentation, I will illustrate the presentation with example of the Azure Kubernetes services, the EKS. And what is important to remember in this case is EKS, that is a managed offer of Kubernetes offered by Microsoft. And the control plane will be under the shared responsibility model on the Microsoft side. And as customer, we will manage the data plane. And if I want to go far about that, in the case of the control plane, as customer, we will have also the availability to customize some parameter, like for example about the API server. We will have the choice if we want to have a private API server, a public API server with an allow list of IP, and we will have also the ability to encrypt the etcd cluster with the CMK, a customer managed key. Now, I want to be sure you understand the different security challenge of a Kubernetes platform. As you can see, Kubernetes is something very complex. And to illustrate this slide, I extracted the top 10 Kubernetes security challenge from the OWASP. And I believe in this case, it's important to understand we will have a lot of challenge related to identity, about how you manage the different identity inside your Kubernetes cluster. As you can see, overly permissive airbag configuration. We will have also some challenge about secret management, because if you store your secret in etcd, by default, the secret is only encoded in base 64. Some tools exist and some add-ons exist to have your secret stored outside of the Kubernetes cluster in an Azure Key Vault, for example. And also, we will see some challenge about the lack of central policy enforcement. In the case of Azure Kubernetes services, we have the availability to deploy a solution like Azure Policy for EKS or OPA Policy or Kyverno. I will illustrate that in the presentation. But let me jump back from the foundation. I believe it's understand to it's very important to understand a security framework when large organizations want to release a new cloud pattern. A cloud pattern, what is it? A cloud pattern, it's a combination of services, for example, an Azure storage, an Azure SQL database with an Azure Key Vault, and this pattern will be offered directly to the application team and will be consumed by the application team. As a security engineer, the first step to do is to do a security review. A security review, that is a technical document where you will deep dive in the cloud services, for example, Azure storage, and we will try to identify all the security capability of the services, and we will try to also identify which configuration we need to apply for the different security capabilities. And one way to enforce that is via the Azure policy. Additionally to that, during the security review exercise, we will also do a list of potential threats. I can give you a real example. For example, if we have an Azure storage account, as a security team, maybe we want to put an additional layer of encryption, and for that we want to use a CM key, and we want to be sure all the Azure storage account deployed in the Azure subscription are leveraging this CM key, and for that we will create an Azure policy to enforce that. It's important to understand the output of a security review. The two main output is to establish a list of security control we want to enforce, and we want to deploy and enforce, and also a list of potential threats if the services is misconfigured. The next step is to do a threat model. A threat model will be a security exercise where we will map all the link between the different cloud services, and we will try to identify the different threats we can have between the different services. And our goal at the end is to define an idea about the security posture of the cloud pattern we want to release. Cloud control validation, that also it's also a very important exercise to do. It's like a security assessment. I don't know if you are familiar with the Cloud Security Alliance matrix, but in the Cloud Security Alliance matrix, you have a framework of security control. For example, you want to be sure all your services are leveraging TLS 1.2, for example. That is the type of validation you will do for your cloud pattern. Generally, we are doing this validation when the application is deployed in non-production. After that, a pen test, specifically if your application is exposed to internet, it's great to have an external pen test. And that also brings another opinion about the security posture of your application. And when we are doing a pen test like that, it's also important to do a pen test at the infrastructure level, but also at the application level. Because if you have a strong application, but in reality your infrastructure is misconfigured, an attacker can target directly the infrastructure part, and from the infrastructure part jump to the application part, or vice versa. A scorecard. Scorecard, that is also important to understand what is it. It's a risk security document, and that will define the risk posture of the application. And the scorecard will be fed with the output of the different security review, the threat model, and also the output of the cloud control validation. And these three documents will feed the scorecard and will help the risk team to define a risk score for this cloud pattern. And finally, we have a cloud governance board where in the larger organization, we have the chief architect, we have the chief security officer, and in this cloud governance board, we will display the scorecard, and in function of the risk appetite of the organization and the risk posture defined and the risk posture shared during the scorecard exercise, they will take the decision or not to move this application in production or not. That was very important for me to highlight this security framework to release a cloud pattern, specifically if you work in a large organization or an organization with some regulation. You have no choice to have a framework like that, and it's important to understand the different steps and why we are doing that. In this presentation, I will focus my time on the threat model part, and I will explain you how you can have benefits to do a threat model in your organization, and more specifically for Azure Kubernetes services. Now, the first question is why are we conducting a threat model? I have this question every time. The first thing is the threat model will review the architecture. In the threat model exercise, we will review the architecture. We will map all the different links between the different cloud services. We will identify also the different threat actors and the different security risk we can have. And sometimes we will have also some combination. That means if you are leveraging the service A and the service B together, that will be a new risk. It's also very important to be sure we have the right compliance in place, the right security control in place. And in the threat model, when we will list all the different threats, we can map this threat to the security control we have already identified in the security review phase. That will also help the organization to have an incident response plan and to understand the full scope of this new cloud pattern, and also in terms of optimization of resource allocation. In this case, I speak about people, because we will target the effort on the weaknesses components, and that will help us also to say, okay, now maybe we have some work to do in terms of encryption, and the security team in collaboration with the cloud engineering team will focus more time to achieve this gap and try to resolve this different gap. And overall, that will also give a good idea about the security posture of the pattern, and also the resilience and the availability of the cloud pattern. Currently, some methodology exists already. In this slide, I highlighted three main methodology you can use to conduct a threat model: the DREAD, the STRIDE, and the PASTA. The more popular one is STRIDE and DREAD. What is interesting in the case with the STRIDE methodology, it's a methodology which focus with an offensive view, with an attacker view. And the DREAD methodology, in this case, I will try to share some example of the DREAD methodology in this presentation. What we will do is we will assign score to each different threat, and we will try to review all the different score, and that will give us an idea about the security posture. But before to jump on that, it's also important to identify which threat actor you will have. And that will depend about the nature of your organization, the nature of your application, because sometimes the threat actor could be some end users, that could be also some internal insider, but that could be also some activists, organized crime, or sometimes that foreign intelligence services like nation-state attack. That is also very important, because you will not put the same remediation effort and the same security effort if it's an internal insider versus a foreign intelligence services. Now, I wanted to highlight some example of threats we can have in the Kubernetes cluster. In this case, I put some threats. For example, the first one, etcd. As I said in my introduction, in the case of Azure Kubernetes services, the etcd part is a critical component, because we will store all the Kubernetes secret, all the Kubernetes configuration in these key value services. And when you are leveraging the Azure Kubernetes services, the etcd is encrypted by Microsoft, but you are also you have also the capability to add another layer of security and encrypt the etcd with your own CN key. And that is also very, very important. As I said, also one critical part in a Kubernetes cluster is a node, because if someone compromises a node, from the node it can steal, the different key and certificate to access to the API server. That's the reason why we try to have a strong security at the node level, and not run container as root, for example, or container with privilege. And also in terms of networking part, by default, if you deploy an Azure Kubernetes cluster, all the different pods inside the cluster can talk together, and that is also very important to put a network isolation in place with network policy, and to have like a default baseline of network policy to prevent that. Now, I wanted to take the time to illustrate a new methodology to conduct a threat model. And this methodology will use, in the first step, an architecture analysis, a second step, an access control mapping, third step, that will be data security. We will highlight also what is related to logging and monitoring, and also what is related to compute and network security. As I said just in the slide before, the compute and network security are a critical part in the cluster. We will also highlight all the security control, and we will do a mapping between the different threads, and we will put an emphasis on the compliance part, and finally we will have a summary of all the threat and risk. And that is a new methodology I would like to share with you today. That is little different about the current methodology like Stride or Pasta or Dread, because in this case what we put an emphasis about a technological view, and also we will include lot of steps related to an architecture analysis, because from my opinion, I believe it's not possible to conduct a great threat model if you don't understand correctly the architecture and the different challenges associated with this architecture. And to do the architecture analysis, what you can use, we are lucky because Microsoft released a document, a Microsoft Fast Track for Azure architecture review, and you can use that, to do your architecture analysis, and you will have some assessment question you can ask directly to your application team or to your platform engineering team. Question about data volume ingestion, about data classification, data security, about also the link with a different third party, and that will help you to have a good idea about the security posture and a good idea about the security posture and also the architecture of the application. Access control, that is also something very critical. As I've said also before, the identity piece, that is also one main critical piece, specifically in a Kubernetes cluster, because we will have some interaction with some external provider like Microsoft Entra ID. You will use maybe some managed identity. Additionally to that, maybe you will have also you will leverage some local Kubernetes service account. That is also very important to have a good picture of that and to try to identify that, because for example, if you detect some identity type like a service principal, that is something you want to avoid, because you will have a secret for that, and you don't want to manage secret. And also about the service principal, I want to highlight your attention about that is if you don't have a Microsoft Entra ID P2, it's not possible to enforce conditional access policy to the service principal. That means if someone steals your service principal and you are not doing any rotation of the service principal, someone can reuse the service principal from an illegitimate internet access, for example, from his from a public hotspot or from his personal internet connection, and access via the service principal to your Azure platform. Next one is data security. It's also very important to do a data flow to summarize all the possible access between the data job and the data running on the Kubernetes cluster. I put an example here, and in terms of risk, what we want to be sure is to have the data correctly encrypted. We want to have maybe some security control like feed level encryption, private endpoint, TLS. You want also to review the airbag configuration to follow the principle of least privilege. All of these different control will be very important, because at the end we are building a Kubernetes platform to host application, and also this application will consume data. But as we said, our control is the data, and that is a part you don't want. You don't want to have a leak or breach about the data. And from my opinion, you should to put a large emphasis and lot of time about data security. And the first step to do about data security is to do a data discovery exercise, because sometimes the application teams are not very aware about which type of data they have in which services. That could be an Azure SQL, that could be an Azure Storage account. And to do this data discovery and data classification, that will be the first activities. And after that, you can evaluate the different risks and put the right security control in place. But please do that. And for that, Microsoft can also help us leveraging solutions like Microsoft Purview, for example, to help you to do automatically this data discovery. Logging and monitoring is great to have logs, but it's better if you are also able to react to this log. Specifically, if you have a log with a security incident, for example, you want to have some automated process to react to the logs. And also, it's also important to store this log. Specifically, if you work in a regulated environment, maybe you will have some regulation who will impose you to store the log, for example, for 5 years, 7 years. I want to highlight your attention about that. And the log retention part is very, very important, and to have a policy about that, because from what we can see from the market, people sometimes will keep the log forever, and they will not rotate the logs. That will cost you money, and that will be also a default of compliance. And the logs, that is very critical, specifically if you have a security incident that you need to do some forensic investigation. And what you want to have is to forward all your log to an immutable log storage account. And in this case, you will have the attestation. No one can compare the log and modify the log. That is also something very important. Compute and network security, as I said, that is also a big topic, specifically about the permission you will give to access to the EKS node, because if someone access to the EKS node, he can usurp the identity of the node, and from the node do a lateral movement to move to the API server and try to compromise your Azure Kubernetes cluster. And in addition of that, it's also important to understand, which egress traffic you will open for the EKS node, because sometimes when you will have your Kubernetes cluster, sometimes you will have a UDR route to forward all the egress traffic to an Azure firewall, and you will open some role to the Azure firewall. But if you have some permissive rule in the Azure firewall, maybe a malicious attacker who has already an access in your pod can use this path to exfiltrate data, for example. And also, it's also very important to understand in this case, if you have a critical workload where you don't want to have egress communication, and what you are looking for is to have like an air gap cluster. That is something possible. Microsoft releases an EKS isolated cluster. Before that, they call that EKS air gap, and that is in public preview, and that will move to LGA in the upcoming months. And that could be also very interesting in your case if you have a very critical workload and you want to have a fully isolated environment. Security control, that is one of my best parts of the presentation. It's because it's great to deploy secure cluster, but if you don't have a solution to enforce security control, like to have like a policy which limits which define the maximum resource limit for your different pod, or prevent the container to be deployed in the default namespace. From a security perspective, that will be very hard to manage. And what you need to have in this case is to have a security policy enforced in deny mode. I know that could be very challenging, specifically if you have already some existing cluster where your application are running on this cluster, because you don't want to break the application. But if you can include the security control part from the day one, from the architecture phase, that will be very easy and helpful for you. And for that, we have three main technology to do that. If you want to play the game to be fully native with Microsoft, you can leverage Azure Policy for EKS, or you can deploy your own implementation of OPA Gatekeeper or Kyverno, or you can create your custom admission controller. That will depend about the time you want to invest for that. From my experience, what is also very important to have is you can start with detective control. In this case, you will have the alert, but no action will happen. Nothing will be blocked. You start with audit policy, and after that you convert this policy to audit policy, to deny policy, to prevent the action. But what is also interesting to have is to have like preventive policy, not preventive, auto remediation policy. That means when an alert will fire, automatically you will have, like, for example, a logic app, and this logic app will automatically fix the misconfiguration in the cluster or in your Azure platform. That is the next step. But if you start with security control currently, and you start only now, start with audit policy, preventive policy, and when you have a good security maturity and a good adoption of the preventive policy by your different team, after that you can move to the next step to have like auto remediation policy. As I said, regulatory compliance, that is something also you want to have in your threat model, because sometimes you will have some security control you want to put in place. And specifically, for example, I can give you an example with PCI DSS. For example, in PCI DSS, if you have compliance with PCI DSS, you need to have TLS 1.2 encryption enabled across all the different communications. That means if you have your different pod running in your EKS cluster, for the communication between the interpod communication, you should to have TLS 1.2, and for that you will have no choice to deploy a service mesh solution, for example. That is a consideration also very important to take and to highlight in the threat model. I put some example on my slide, and if you have any question, feel free to reach me on LinkedIn. And to help you to start with all these different threats and control, Microsoft created this threat matrix specifically for Azure Kubernetes services. But you can use that also if you have also some on-prem deployment of Kubernetes, or if you are leveraging OpenShift or AWS EKS, for example, because a lot of these threats are very generic and focus only on Kubernetes and not specifically for Azure Kubernetes services. And finally, that is a threat summary. In the threat model, you will create a threat summary like that. With the threat methodology, you will calculate the risk rating for all the different threats. And what is important is for each threat to highlight the different mitigating control you will put in place. In terms of area of improvement, to do threat model, that could be a painful exercise. specifically if you don't have a cross functional team and you don't have all the stakeholders engaged to help you to understand all the application will work, all the cloud pattern will work. And also, because you are doing a threat model at, for example, in December, but maybe next year the threat model will be completely outdated, and that is also an area of improvement you should to put to keep your threat model up to date and revisit maybe every quarter the different threat model you have created in your organization. And what could be interesting is to leverage AI. I know everyone is speaking about AI today, and we can't do a presentation without to speak about AI. But specifically in the case of threat model, it's important to explore the different options you can have to help you to use the power of the AI with a large language model, with LLM, if you're leveraging, for example, OpenAI, that can give you some idea about some potential threat. But you can also create your own LLM engine for that. And additionally to that is also very important to have like a concept of pattern recognition, because when you create multiple cloud pattern, sometimes you will use the same component. For example, Azure storage account. Okay, Azure storage account can be in 2 or 3 threat model, and sometimes you will have the same threat. And versus to just redo the exercise from the day one. Maybe in this case that could be great to have like a library of threat and just copy paste the threat you have already identified for Azure storage account. And when Azure storage account will have some new security feature or new capability, when you will revisit the security review, maybe you can add also this threat to the library, and in this case you will have an updated library of threat, and you can reuse this different threat in your different threat model. And that is, from my opinion, that is something AI can do, because it's easy with an AI engine to do pattern recognition, and also to help you to improve your threat model with NLP. I don't know if you are doing some fire drill exercise, or maybe if you have any threat intelligence feed or incident report, maybe train the LLM engine with this different documents to improve the quality of your different threat model. And the risk scoring also. The risk scoring can be done by an AI engine. The good thing to do that is, in this case, is you will not have a BA, if I say that, because the risk scoring will stay consistent, and that is very important. Takeaway to close this call, to close this presentation. As I said, understand the architecture, have a comprehensive knowledge about what's the goal of the application, what's the goal of the platform. Try to also explore some tools to automate compliance and compliance check. And maybe you are leveraging tools like Checkoff, or I don't know, maybe Microsoft Defender for Cloud, to have continuous monitoring. And what is great in terms of as a people who are doing a threat model, it's also great to check the different security control they identify, because that will also give you some idea about some potential threat you can have for your application. Review and update the threat model. That is a very key point, and that is a very challenging part to automate. You will have no choice to have human and people who will update the threat model, because, as I said, if you are doing a threat model, for example, today, maybe in 6 months, the threat model will be completely updated. And collaboration. That is also a key element to do a successful threat model, is to involve the different stakeholders, the business, the application, the different SRE team, to work with the security, to understand and to have a comprehensive and holistic approach about the potential threat we can have for the application. I put some resources about that. I put the link to the Kubernetes threat model created by the CNCF, the Cloud Native Foundation, the financial user group. They created a good threat model for Kubernetes. I put also the link to the Kubernetes SIG security, my blog. I try to blog about EKS security, cloud security, Kubernetes security. And if you have any questions, feel free to reach me on LinkedIn, for example. And also I put also some three very good book, specifically if you want to do a threat model. It's great to have some good security foundation and good security understanding of the Kubernetes platform. And the second book, Hacking Kubernetes, is very great. I will recommend you. And thank you so much to attend to my presentation. As I said, maybe 5 times during this this session. Feel free to reach me if you have any question. Let me know if you want to share also any feedback. Feel free to let me know that. I'm also still curious and very open to know maybe how to know different way to do threat model. If you are using another methodology or some other concept to do your threat model, feel free to share that with me. And I will wish you a very great time, a very great end of year time, and take care of your family, of your friends. That is the most important thing to do, I believe. And see you soon. Thank you.